everyone, and welcome to my new series, Mach4 Basics. With these videos, I'm going to be addressing some common questions and concerns for anyone who considers themselves a beginner. The intent is to bridge the gap between the developers, the lifelong machinists, the experts in their field, and those hobby users who are just starting out with little to no knowledge about the world of CNC. Today, I'm going to begin with the basics of homing and soft limits. Now, your machine operates in a coordinate plane environment, a grid. You have your x-axis and y-axis, which are perpendicular to each other. The z-axis adds the third dimension, height. To keep everything aligned properly in your grid system, your machine follows what we call the right-hand rule. Hold your right hand out with the palm up. Now make an L with your index finger and thumb and stick your middle finger straight up in the air. Your hand should look like this, and each of your fingers are pointing in a positive direction of travel. Your Y is your index finger, your X is your thumb, and your Z is the middle finger. Now you can turn your hand in different directions, since your machines won't necessarily all be lined up the same way, but the right-hand rule still applies. It's important that your machine obeys this rule because your design software is going to assume that it does, and then write your G-code based on that assumption. Your machine coordinates are what I like to think of as your base level grid. Because your machine exists in the physical world and our software exists in a virtual world, we need to sync them up. To put it simply, Mach4 doesn't know where your machine is until you tell it. This is done by homing your machine. When you home your machine, you're designating a specific point as your x0, y0, z0 position. You're choosing a physical location on your machine and assigning a virtual label to it. The rest of the grid is assembled around that point and is known as your machine coordinate system. Once you've homed your machine, those machine coordinates don't change unless the physical conditions change. For example, if you lose steps or crash your machine. So you'll want to home your machine and establish your machine coordinates every time you start Mach4 and power up your machine. Now let's talk about work coordinates. Like your machine coordinates, work coordinates are a grid system used to calibrate the physical world with the virtual. Work coordinates are what you'll normally refer to when running a G-code file and are established by zeroing your machine, rather than homing. It's a very similar process. You are designating an x0, y0, z0 position and establishing a grid around it. However, these work coordinates can and do change. You can change them by using tool and work offsets, for example. I'll go over those topics in another video, but for now let's keep it simple. Your work coordinates are the functional grid you use and refer to most often at Mach4, and they exist as a separate layer on top of your machine coordinates. They are established by zeroing out your axes and do not affect the machine coordinates you set up through homing. So let's move on to the how of homing. There are two ways to home your machine with Mach4. You can use home switches or you can home in place. Home switches are set up as inputs, and when they are touched, it sends a signal to let Mach4 know you've reached your home position and to set your machine coordinates to x0, y0, z0. Homing in place takes whatever your current position is and sets that to x0, y0, z0, no movement involved. Home switches are more reliable and allow you to consistently home in the same position. That makes things like setting up soft limits easier. However, not all machines are equipped with these switches, and homing in place is the option you'd use in those instances. Personally, I recommend picking a spot in your machine and marking it with a sticker or some other indicator so that you can home in place as close to the same spot each time. Your homing behavior is established in the Homing and Soft Limits tab in your Mach4 configuration menu. You'll have the option to select your home direction, home order, home offset, home speed, and whether you want to home in place. You can set up your soft limits in this tab as well, but we'll hold on to that one for later. Most of these options are only applicable if you have home switches. Home direction sets the direction your axes will move when you home your machine by clicking Reference All Axes, Home. They will continue moving in the set direction until the home switch is triggered. The home order establishes which axis will be homed first, second, third, and so on. The home offset allows for shift from the home switch position. This can be used to adjust the home position if the home switch is not located at the end of travel. Home speed determines how fast your axes will move while homing. The percentage you set is based on the max velocity you have assigned for that axis. If you have no home switches, you can choose to home in place. When you reference all axes, your current position will be set to x0, y0, z0 in your machine coordinates. You can use this option on one or all of your axes. For example, if I have a home switch for Z and X, but I don't have one for Y, I can set Y to home in place. Reference All Home will still send Z and X to their switches, but Y will home right where it is. I want to show you the two options we have for homing so you can see what you're getting into. First up, we have our blue router, which has home switches installed. That means when I click Reference All Axes Home, you can see the machine begins to move towards them. Remember, we set up our homing direction and other behaviors in the Homing and Soft Limits tab in the Mach4 configuration menu. If you look closely, you can see a home axis tripped message appear in the status bar at the bottom of our screen each time a home switch is pressed. You'll also see the LED beside the DRO light up green when that axis has been referenced. Finally, we will get a pop-up message letting us know our machine has been homed. This 3040 router doesn't have home switches, so I'm going to set it to home in place using the Homing and Soft Limits tab. Now, I just need to jog to the spot I want to use as my home. I'm going to use the corner closest to the camera for the X and Y axes, with the Z axis all the way up. Now, once I press RefAllHome, you won't see any movement from the machine, but the LEDs besides each DRO will light up green and our machine coordinates will change to 0. Finally, we'll see that telltale pop-up letting us know we succeeded in homing our machine. Now, back to soft limits. Soft limits, or software limits, use your machine coordinates to establish a safe area for your machine to operate in. Even if you have limit switches, soft limits can help prevent crashes and keep you and your machine safe. In the Homing and Soft Limits tab, you can input a soft minimum and a soft maximum for each axis. These values are the most positive and most negative points you want your machine to be able to reach based on your machine coordinates. Remember, homing is what establishes those machine coordinates. That's why it's important to be consistent when homing your machine, especially if you're homing in place and not using physical home switches. If you home over here one day and set up your soft limits based on that home position, and then home over here the next day, your soft limits are not going to be effective. So you have two options. Number 1, home in the same spot every time to the best of your ability. Or number 2, set up your soft limits each time you home somewhere new. To figure out where your mins and maxes should be, you want to start from the home position. On this machine, that's here. From here, we can only move in a positive direction for our X and Y axes, so our soft min is going to be 0. You can't get any more negative than that on this machine. If your home position is somewhere else, you'll want to start with the X axis and jog it to the farthest point you want to allow in the negative direction. Once you're there, look at the machine coordinate DRO for that position, you can do that by clicking here, and enter that value as your soft min. Do the same for Y, and then Z. Next, head to the most positive direction you want to allow and enter each value into the soft max field. Don't forget to check the box to enable your soft limits. You're also going to need to turn on your soft limits using this button here. Another benefit of soft limits is that they provide an outline of your table surface that you can display in your toolpath. It's a quick way to show if your project is too big or positioned outside your work area. To turn that feature on, go to Configure, Mach, Toolpath, and check the Toolpath Limits box. Once the toolpath regenerates, you'll be able to see a cube outlined by my soft limits. It's a little faint, but it's a good visualization of all the soft limits that we just set up. One thing to remember about soft limits is that they need to be turned on to be effective. Even though they're enabled, they aren't active until you turn them on. To do that, again, use this button here. Now you can also change some scripting so that your soft limits automatically enable after homing. I think this is a great idea, so I'm going to show you how to do that. In the description below, you're going to see the script, which I also show here in the video. Copy that and open Mach4. Head to the screen editor by clicking Operator, then Edit Screen. We're going to be editing the screen load script, which you can get to by clicking on the topmost line of the screen tree manager here. Down at the bottom, we're going to switch to the Events tab and click the 3 dots beside the screen load script, which is going to open it. Now scroll way down until you see the RefAllHome function, which is around line 198. We're going to delete everything in this section and replace it with the script that I provided for you. Next, we're going to go to File, Save As, and pick a custom name for the screen. You want to leave your default screen as it was and save any changes you make onto a custom screen set, so you have the option to change back if you need to in case you make any mistakes, or if you update your Mach4 later on and you don't have your screen saved as an original name, they might get overridden. Now, whenever we click RefAllHome, we're going to see the machine coordinate DROs change to 0 and the soft limits on button is automatically lit, so we're good to go. Now that we've learned all about homing and soft limits, let's review. Your machine coordinates are the base level grid that you create by homing your machine. Your soft limits and offsets are calculated based on that grid system. Work coordinates are the grid system your G-code operates in, and they are established by zeroing your axes. Software limits, or soft limits, are an added layer of protection for you and your machine. They are created by mapping out the boundaries for each axis and choosing a minimum and a maximum. They need to be enabled and turned on to be effective. A small edit in your screen load script allows the Reference All Axes Home button to turn on your soft limits automatically after homing. Remember, if you have any questions, please send me a message using the help desk at support.mach4.com and subscribe here for more Mach4 videos. As always, happy CNCing!